Alright guys, there we go. This is chapter 4 review for 1513, which I totally forgot about until just now. And I didn't bring any of my stuff home, and I don't have any paper or anything at home. So if you look very closely, I'm writing on the back of an envelope. I don't even have any freaking paper at home. Alright, so here's a quick review of chapter 4 for college algebra 102 through 109. Basically the same problem over and over and over again. You got to be able to change exponential to log or log to exponential. So be able to go either way. Given a log, whatever number is by itself, remember that's your exponent. The exponent always goes back on the little bitty number, which we call a base. So the exponent of 4 goes back on the base of 3. Looks like this. The exponent of 4 goes back on the base of 3. So exponential looks like that, has an exponent. Log form looks like this, has a log. Same thing on this right here. Remember, if you don't see the base, it's either 10 or it's e. If it's a regular log and you don't see a base, it's 10. If it's a natural log and you don't see a base, it's e. So on this one here, we call it a common log when it's base 10. We're going to put the exponent of 2 back on the 10, like this over here. And this one here's a natural log, so we don't see it, but that's an e, a base of e. We're going to put the exponent of 8. It's the number that's by itself, whether it's on the left, or on the right. The number that's by itself is your exponent, and the 8 goes back on the base of e, just like that. All right, 110 and 111 are basically the same. They say something like evaluate this log. Well, what they're saying is what exponent goes on that little bitty 2 right there to give you 4. So 2 to the what power equals 4. What they're leaving off over here is equals x. We usually put that on. But they're going to give you the problem like this. I like to go ahead and add equals x because it looks better to me. So I'm asking what exponent goes on the 2 to give me 4. Now that's a pretty easy one. It's not going to be that easy on the test. You could guess it. It'll be a tougher one on the test, but you do it the same way. You just do change of base because most calculators don't speak base 2. So we change the base to base 10. Both of these are base 10. So log of the big number, base 10. Log of the little number, base 10. And now anybody's calculator will do this. Log 4 divided by log 2 is 2. So if you have one of the older calculators, you just use what's called change of base and do log 4 divided by log 2 to get the exponent that we're looking for. If you have one of the newer calculators, you hit the log button and there's a little box here and a little box here. You can put the 2 in the little box and the 4 in the big box. You guys, your calculators will speak any language, so you can just put it in that way. But if you have the older calculator, it's just change of base. Log of the big number divided by log of the small number will tell you the exponent. Now to check it, if you say that this is the exponent that goes on the 2, well, just check it that way. Put this exponent on the 2. Raise this number to the second power and make sure you get the big number. All right, same thing here. Log, evaluate log of 1/1000th. What they mean is what exponent goes on the 10 to give you 1 over 1,000. I like to write it this way. I like to add the equals x. We're going to use, if you forget, just use change of base. So log of the big number, 1 over 1,000, divided by log of the small number, log of 10, equals x. Now this is kind of the long way to do it, but it'll get you to the answer of -3. Anybody's calculator can do that. If you're on the ball, you can recognize that this is base 10, and everybody's calculator speaks base 10, so you really don't have to do change of base because you're already in base 10. Your calculator speaks this language, so you can just hit log of 1 over 1,000 and go straight to -3. So this is kind of overdoing it, but I figure that some of you guys might forget, and it's okay to use change of base if you forget. You're not really changing the base. It was 10 and it's still 10, so you didn't change the base, but it's okay. You can still get the answer this way. This one here just adds an extra step. It's whatever you are looking for. The exponent that you're looking for times 9. All right, it just depends on your calculator. I'm going to do it the old-fashioned way. I'm just saying I don't have a calculator that does the box thing. So if I have the older calculator, I'm going to ignore the times 9 just for a second, and I'm going to figure out what exponent they're asking for here. They're saying what exponent goes on the 10 to give you 1,000. Well, you can do it the long way and do change of base, log of the big number over log of 10. That's kind of the long way. Or you can recognize that that's already base 10, so this will go into your calculator. Your calculator speaks base 10. Either way, you're going to get to 3. So the exponent that goes on the base of 10 is a 3. So this is 3. And then 3 times 9 to finish it off. We just have to remember, once we find the exponent, you got to multiply it by that number out front. So 3 times 9 is 27. That's kind of the long way, for the older calculators. You guys that have the newer calculators, of course, you can pull up log and box, and you can just put the whole thing in. So 9 log, you can put a 10 in the little box and 1,000 in the big box. That's kind of overdoing it because, again, everybody's calculator speaks base 10. So you don't really need the box thing. Everybody's calculator does this. So really, everybody's calculator will do 9 log 1,000 and go straight to the answer. I just did it this way because I know, some of you will forget. You'll panic. And if you panic, just do change of base. You'll get there, multiply it times the number that's out front. All right, I might put a domain question on there. This is 115. If I put one on there, it'll be like your last question, like your 11th question, your extra question. And if I put one on there, it'll probably be just like 115. So to review, we can only take the log of certain kinds of numbers. And if you want to experiment, just take the log of any negative number. Your calculator is going to say error. Can't do it. Take the log of 0. Your calculator is still going to give you an error. So you can't take the log of negative numbers. You can't take the log of 0. But you can put the log of any positive number in and get a real answer. In this case, the log of 100 is 2. So the number that you're taking the log of has to be positive. And when I say it has to be positive, mathematically that means it has to be greater than 0. So when you're looking at your equation again, and I ask you, what's the domain? I'm saying, what can x be? What x's can you use? Well, you know that you can only take the log of positive numbers. So what's in the parentheses here must be positive. Set it up that way. X minus 5 must be positive. That means greater than 0. Plus 5 plus 5x must be greater than 5. And you can write your answer this way. So any number bigger than 5 will work. Or you can use interval notation. Either way is correct. How do you check it? You just take any number bigger than 5 and see if it works. For example, 6. 6 is bigger than 5. 6 is greater than 5. Put it in up here. 6 minus 5, that's 1. And then you can do your thing. Log base 4 of 1. You'll get a weird decimal, but it's an answer. You'll get a real number. So as long as this thing is positive, any number that makes this number inside the parentheses positive, we can take the log of. All right, and these are the ones I'm going to need you to show work on. So probably one question on the test, maybe 2. I'll specifically ask you to show work. So maybe 122, 23, 125, or 126. Be prepared to show work on those, and I'll make a big note on the test that I want to see your work on this for full credit. So basically it's just solve an equation where you don't know the exponent. First step, when you don't know the exponent, automatically log the left and log the right. We're just going to log both sides. So log the left side, log the right side. It's an action that you take. Second step I want to see you move that exponent to the front. So my equation now says x times log 3 equals log 243. And the third step, I just want to see you divide this log 3 away from the x. You guys can mark it out here. Whoops, my pen. Oh, I'm writing in pen too. I told you guys not to write in pen. I told you I'm not prepared. I'm writing in pen on a freaking envelope. Divide by log 3, divide by log 3, x is 5. All right, how do you check it? If you say x is 5, put it in right there. Raise 3 to the 5th power and just see if it equals 243. Let's see, 128, that'll definitely be on the test. It's just the bacteria question. The number of bacteria after a certain amount of time has passed is the number you started with times whatever's happening to it, and for however long you let it grow. This is kind of how fast it's growing, and this is how long you let it grow. So we had 1,700 bacteria. It looks like they're doubling every minute, hour, week, year, whatever unit of time they're using. But it's doubling every unit of time that goes by. They're going to ask you to calculate the number of bacteria after a certain amount of time. Let's say hours. I forgot what it actually said. So the number of bacteria after 0 hours, this is actually our starting point. is 1700 times 2 to the 0. You just change t to 0. Do the math, it's 1700, which makes sense. All right, anything to the 0 power is 1. 1 times 1700 is 1700. That means at the start of the experiment, when time equals 0, we had 1700 bacteria in our dish. That makes sense. What about 2 hours later? The number of bacteria 2 hours later is the number you started with times 2 raised to the second power. That's how many hours we let go by. Work it out. Now you got 6,800 bacteria because they're doubling every hour. If you think about it, 1700, it doubles the first hour, you got 3,400, and then it doubles the second time, and you got 6,800. 129, we're calculating interest. You guys are bankers. Somebody brought you $5,500. You said, I will pay you 4.5% interest on this. How long are you going to leave it in my bank? And they say 20 years. So we got to calculate interest on $5,500 at 4.5% for 20 years. If we're compounding monthly or daily or a certain time period, we got to use the old-fashioned formula. This will be on your test. You don't have to memorize it. So using the old-fashioned formula, P is principal, the initial amount, $5,500, and then 1 plus the interest rate. Make sure you guys can read my sloppy handwriting. This is R for rate, interest rate or rate of growth. This is N for the number of times we're going to compound it. All right, we're talking about interest, so we're going to calculate interest a certain number of times per year. That's the same N, and this is the number of years we let it sit. So we start with $5,500. That's our principal, our beginning amount. 1 plus the interest rate. Remember to change percent to a decimal. You bump that decimal 2 to the left, 0.045. We're going to calculate it monthly. That's 12 times a year. There's the same 12, and we're going to leave it in there 20 years. Here's your exact answer. All right, but we're talking dollars and cents, so I need to know how many pennies I have. Looks like I have 6 pennies. You just gotta, before you throw the rest of them away, you gotta check that next number and make sure the 6 doesn't round up to 7. So that's less than 5, so that stays 6. 13,505 and 6 pennies. Compounded daily, the only thing that changes is the number of times per year that we calculated. If we're calculating interest daily, that's 365 times a year. So both of my n's changed to 365. Here's the raw answer. I'm going to cut it off right here, and I'm going to throw the rest away, but it's not 6 cents, it's actually 7 cents, because this number right here, this 6, tells you to round that up 1 more penny. Okay, make sure you round it correctly to the nearest penny. And last one, 3,800, 6%, 12 years. There's the word we're looking for, compounded continuously. That means you get to use the easy formula. So the amount you end up with is the amount you start with times 2.71828 raised to the interest rate. That's 0.06 for 12 years. Looks like this, 3,800. I don't want to write 2.71828, so we just leave that E. There's 6%, there's 12 years. Here's your raw answer. Looks like 84 cents, but the 6 says rounded up to 85 cents.